Assalamu alaikum. My name is Mishal Fatma and my registration number is 23TE55. In this video, I will explain my artificial intelligence assignment on the topic breadth first search and depth first search. These are two fundamental search algorithms used for exploring trees and graphs in artificial intelligence. They help computers find paths, search nodes, and solve many real world problems such as robot navigation, network routing, and puzzle solving. In this video, I will explain what BFS and DFS are, a simple tree example, a graph traversing example, a robot pathfinding example, and finally the code implementation. First, let's understand what BFS and DFS are. Breadth first search or BFS is a search algorithm that explores nodes level by level. It starts from a root node and visits all the neighboring nodes before moving to the next level. BFS uses a query data structure, and DFS is another search algorithm that explores nodes as deep as possible before backtracking. Instead of visiting all neighbors first, it follows one branch completely. DFS uses a stack or recursion. Here you can see a quick comparison between DFS and BFS. Now let's look at a simple tree example. In this tree, 0 is a source node and it has 3 children 1, 2, 3. 1 has 2 children, 2 has 1, and 3 has 1 either. If we apply breadth first search starting from node 0, the traversal order will be 0, 1, 2, 3, 4, 5, 6, and 7. This happens because BFS visit nodes level by level, and in DFS we visit branch by branch. And if we complete first branch, then second and third. So here will be the traversal order will be 0 to 1, 1 to 4, 5, 2, 6, 3, and then 7. This happens because DFS explore one branch completely before moving to another branch. Here is another example of tree traversal. Next is the graph traversal example. In this graph, nodes are connected like a network. If we start from a node A and apply breadth first search, the traversal order will be A, B, C, D, and E. This is because BFS visits all neighboring nodes first. If we apply depth first search from node a traversal order can be A, B, D, C, E. DFS goes deeper into the graph before exploring other nodes. Now I will explain robot pathfinding example. In this grid environment, robot needs to move from the start position S to the goal position G. In the grid, X represents obstacles that the robot cannot pass through. To reach the goal, the robot uses such algorithms such as breadth first search and depth first search. First, let's look at how BFS work in them. In this example, BF expands from start node step by step in all possible directions. It explores nodes level by level, forming a wave-like expansion. Because BFS checks all nearby position first, the first time it reaches the goal node, it guarantees the shortest path. Now let's look at DFS behavior. DFS follows one path deeply before exploring other possible paths. It keeps moving forward until it reaches a dead end. Then it backtracks and tries another direction. Because of this behavior, DFS might reach the goal quickly, but it does not always guarantee the shortest path. So, in broad navigation problems, BFS is usually preferred when we want to find the shortest and most optimal path. In this, the yellow path in the grid represents the route the robot follows to reach the goal by avoiding red obstacle blocks. Finally, I implemented BFS and DFS using Python. In this program, the graph is represented using an urgency list. So let's run this program. So here is the output. BFS algorithm uses query and DFS uses recursions. In conclusion, breadth first search and depth first search are two important search algorithms used in artificial intelligence. As we studied, BFS explores node level by level and is useful for finding shortest path, while DFS explores node deeply before backtracking and is useful for exploring large search spaces. In this video, we discuss the basic concept of BFS and DFS, a simple string sample, a graph traversal, a robot path finding example, and their implementations using Python.